Good morning, student. Let's start today's class. Today we will study about post convection dryer. Okay. In previous classes, we have studied or we have seen about natural convection dryer. Okay. You remember that the solar dryer are two types. One is natural convection dryer. One is forced convection dryer. Okay. In previous classes, we have studied about natural convection dryer, where the flow of air or the dryer process is done by not using any mechanical or electrical fans or blower. That's why that is called natural convection dryer. But in forced convection dryer, we use fans, blowers, and some mechanical uh, but mechanical instrument to circulate air or to store heat or so many things to do. That's why it is called forced convection dryer. The essential difference between a natural convection dryer and a forced convection dryer is that in the latter a fan or a blower is used to maintain the desired rate of flow of air through the drying product. This is the basic difference between natural convection dryer and the forced convection dryer. That in forced convection dryer we use fan or blower to circulate the air or to get the desired rate of the flow of the air in the drying process. Okay. There are various variants of such dryer described in the detail by Sodhal. So that from an industrial dryer point of view, one has to use a convectional source of energy along with a source air heater, solar air heater, solar heater for a 24-hour operation. Okay, the schematic of that means what it tells that we use both solar collector or and a auxiliary heater. Okay, auxiliary heater or auxiliary source of energy to heat our product for 24 hours, because solar heater can cannot give heat energy in night time or cloudy time, cloudy days. Okay, at that time the auxiliary source or conventional source of energy used to heat our product. Okay, here what happened, there is a inlet fan which give the air to the system from and outside, and give the air and give the air through the solar collector. Okay, through the solar collector, and that air is heated due to the solar radiation falling on the solar collector, and the heated air or air going through the storage and store some portion when storing, and the storage is used only when peak summer or peak hot days are there. There is so many of energy produced or so many of hot air produced, but that much hot air we cannot use or we don't use for our drying process. So rest hot air stored here for backup purpose or for cloudy days or night purpose. Okay. After storing That after storing the amount how much we need for our drying process, that going through auxiliary sources, and one fan is circulating in drying chambers, inside drying chambers. Okay, then after circulating in the drying chamber, inside this drying chamber our product is there. Okay, after circulating inside the drying chamber, that hot air going out through heat recovery limit. That means here this hot air, what happened, the hot air get cooled and going to the inlet fan and recycle the process again. Okay, the basic component of such a unit are solar aerator, okay, blower, auxiliary energy unit, and storage unit. The storage unit is provided for making the use of excess solar energy during peak radiation hour and delivering it to a ambient air during low radiation or no radiation period. The storage system often used in rock bed storage system. That means in storage system we often use what, the rocks, big rocks, which heated due to the hot air going inside the storage and remain heated for many times, and when we need the hot air we circulate the air inside the or through the hot rocks and get a hot air from it. Okay, next we see what is solar pond. Okay, solar pond, also called a salt pond, is an artificially designed pond filled with a salty water maintaining a definite concentration gradient. It combines solar energy radiation and sensible heat store, and as such it is utilized for collecting and storing of solar energy. That means solar pond is a pond, okay, but in that pond general water is not there, salty water is there. Okay, that's why it is also called salt pond. Okay, and due to the salt and the water or salt concentration in the water, in that pond water is not same, there is a different layer of salt water in the pond. Okay, that's gradient or solar concentration gradient, this salt concentration gradient, due to this difference concentration gradient, the solar radiation which pass through or which fall on the water surface is captured and stored as a energy, okay, inside the pond. So we use that pond as a solar radiation storage or radiation conversion device. Okay, that's why it is called solar pond. Okay, a solar pond reduces the convection and evaporation heat losses by reversing the temperature gradient with the help of non-uniform vertical concentration of salt. That means in general our general pond, there is a heat loss due to convection heat loss due to convection, and convection means reflection. Okay, solar ray reflected, and evaporation of mm, water vapor, that losses is reduced by using the salt level gradient in the solar pond. Okay, in vertical configuration of salt gradation, solar pond normally consist of following three zones. That means the pond having three zone inside vertically, that okay, One is surface concentrate, surface convective zone, which is SCZ. That means here you see this is the pond. This pond here three levels: level 1 and level 2 and level 3. In level 1 is SCG. That means surface convective zone. Okay, this is surface convective zone. Here salt concentration is very low. Okay, and very low. And second layer is called lower connective zone. Okay, it is at the bottom of the pond, and this layer will highest salt concentration where high temperature are built up. Here this layer lower what is lower connective zone. Okay, this is lower collective zone. Okay, this zone have a high salt concentration, and that's why it store energy, the radiation energy store here. Okay, the sun radiation energy store here. Okay, most of the sun radiation energy. Okay, then third level is concentration or intermediate gradation zone. Okay, concentration gradation zone. Okay, this zone gave the two convection zone SCG, and this this zone this zone 3 CGZ. Okay, this concentration gradation zone separate the two layers. This layer is low salt concentration, and this layer is high salt concentration, and this zone 3 separate these two layers. Okay, and make a what make a uh, make make a insulating. It provide excellent insulation for the storage layer. That means it provide insulation for storage layer. The storage which store uh, solar radiation. This layer 3 didn't allow the loss of that stored energy. Okay, and the major heat loss is due to the surface of the solar pond occurs in the solar pond due to the blow of air touch the surface of the pond, and cool down the water. That's why if we place a or prevent that loss by using spreading a plastic grid or plastic polythene uh, at the surface of the pond, that then our then their loss is reduced, and 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 one loss they one and due to the concentration of salt in the layer 2 or bottom layer is very high, so we should insulating it from the ground, because if we don't insulate it, then the salt concentration goes to our earth. Okay, so we insulate it from the ground water or ground surface. Okay, and now see application of solar pond. Okay, this solar pond used in power generation. Okay, space heating or cooling, crop dryer. Okay, distillation and process heating. Okay, limitation. What is limited? This requires sunny climate. Okay, this require high concentration of radiation, need for large land area. Okay, to to dig a pond, we need a large area, availability of salt. That means we need some very much amount of salt, availability of water. We need water for pouring the pond. Okay, that is the limitation or disadvantage of this pond. Okay, thank you.